Hi, I'm Craig Grant and this is Cobweb Maths. In this video, it's going to be in two parts. In the first part, I'll give you some background on type of techniques I use, and then I'm going to focus on two specific examples and show you the concrete concept that I use to work these out. And then I'm going to do a second part and show you how you can teach equations to young children using a story and concrete things. Now, this part is background. Now, I've taught my class the concrete concept, and from the concrete concept, I have taught them the key concept. Now, the key concept in equations, mathematical concept, basically do the opposite to both sides. And I give them an example, well, a couple of examples. Like this, x plus 3 equals 5. So what they do is they look at the equation. What are you doing? You are adding 3. What is the opposite of adding 3? Subtracting 3. Therefore, you have to subtract 3 from both sides. Right? And I get them to work in columns like this, this, and this. So the x goes there, the 3 take away 3 is nothing, so they put nothing there. The equal sign goes there, and 5 minus 3 is 2, and they've done the question. And then I give them a sequence of questions to do. Now in my class, I'll have fast trackers and I'll have a tail end Charlie or a tail end Charlene. Now, this sequence of questions is designed so tail end Charlie gets to here. Now that's the thinking person question, all right? So I want them to have a crack at that. I will go into the rationale behind the thinking person question in another video. Now, the other thing is I've got to look after my fast trackers. Now, that's for my fast trackers. They get through that question. I don't want them sitting around fiddling their thumbs. I want them to try this one. This is the everyday genius question. All right, so I've underlined that there. So what will happen is they'll go through these questions. Everybody will have a crack at that one. The fast trackers will have a go at this one, and probably none of them will get it. Well, maybe some will. Who knows? There's always somebody who'll do it, or maybe. Anyway, in sequence 2, what I do is I take some of the questions out of sequence 1. There's a couple there, and in the review of sequence 1, I go through this and I show them a way of doing this, right? So everybody knows. It's like a race. They all start again. They have a chance to go over these questions here, which they had here. Here's the step up, right? So they get a chance to do those. Now, here's the thinking person question. Outside their experience, but if they think about it, they may be able to do it. And if they can, then they go on to this. Now this is very similar to this. Okay, so that's the background. Now, I'm going to use story power to work out this question here. And I'm going to use a concrete concept. I'm going to use going to a shop and buying things as a concrete concept. So, we'll tell the story. A man walks into a shop with $7. He buys 2 exy things and he works out with $1. All right? So, he got in with $7, out with 2 things and $1. So you ask them the question, what do the 2 things cost you? Well, they can come up with it, $6. I mean, that's pretty straightforward. I said, well, if 2 things cost you $6, what will 1 thing cost you? And they'll say, oh yeah, well, that'll be $3. Okay, and they're done. All right. Now, the other question, very similar. So, the man goes into the shop. We'll make it a woman. We better be make it a woman this time. A woman goes into a shop with $7. She comes out with 2 exy things, or we'll just say 2 things, and she owes the shopkeeper $1. So the cost of 2 things is $8. So the cost of one thing will be $4. And if you want to, you can link the story to the working. There it is. You go into the shop with $7, you buy 2 things, and you've got $1 too many. So what do? Well, you go in with $1 less. You go in with $1 less, right? There you are there, $6, buying 2 things. Take one away from both sides. Then divide both sides by 2, and you find that the X value is 3. Similar for this one here. You add 1 to both sides to disappear the -1. See, there's 2x there, there's nothing there, and there's 8 there. Divide both sides by 2, there's x equals 4. And you can link it up to the working. And if you're doing equations, the working is important. And we've finished this part now. This is how I'm going to teach children to solve algebraic equation. Here's the algebraic equation, x plus 1 equals 3. Now you know that 3 is equal to 3, so we just use these red nuts right here. 3 red nuts here have to equal those 3 red nuts here. Now this x is a bowl, all right, bowl. So we've got 3 nuts here, we've got 1 nut here, so what does that bowl there represent? Well, we could do this, and then we could do this. And we would have 3 red nuts here, and 3 red nuts here. So x would be 2, because 2 plus 1 is 3. Now let's take everything away. So how would you go about teaching it? Well, I would start with x plus 1 equals 3, and then say, well, we know that 3 is equal to 3. And then we would put down 3, and we put them together. Well, there's 3 there, and there's 3 there. All right, and we could say, well, x is a bowl. There's the bowl there, and there's 1 nut there, and there's another 3 nuts here. Now on this side we have 3 nuts, and this side we only have 1 at the moment, and then for them to be equal we've got to have 3 nuts over here, but we've got a bowl. So what we do is this, we put that there like that, and put those in the bowl. So the bowl is actually equivalent to 2 nuts. So I'll take the bowl away, I suppose. There it is. Right, 1 plus 2 equals 3. 1 plus 2 equals 3. So what was in the bowl was 2, and that was the answer. Right, we'll take all this away, and we'll try another one. There it is. 2x equals 6. Okay, so that's the equation. We start with 6 is equal to 6, so we put 3, 4, 5, 6 there, and on the other side we put 1, 2, 3, 4, 5, 6, and the children can count them out that way. And then on this side we've got nothing but 2x, right? So we've got 2 bowls. Now on this side we have 6. Oh look, I'm 1 short. I better take 1 from here. Right. And anyway, these 2 bowls are equal. So you see, we could have 3 nuts in there and 3 nuts in there. and we'd have 6 nuts over there. So what's in each bowl? There's that's like an X. X is 3 nuts, there's 3 nuts, and there's your 6 nuts. And we're pretty well done. If we tip it out, we can go like this, and maybe put them this way, might be an idea. So that's 3 plus 3 is equal to 6, and so X must be 3. And we're done.